We're going to carry out a ring final circuit test. And for that test we need a low resistance ohm meter with the leads zeroed. We need to turn the instrument on to ohms, join the leads together. If I push the button and then zero the leads. As you can see, I've already disconnected the leads from the distribution board. These are our ring circuit leads or cables, and they're identified. It's very important that each end of the ring is identified so that we know which one goes to the first socket and which ones come from the last socket. These are just identified with a bit of grey tape. Most people can use tape or numbers or whichever way you prefer. As long as they're identified, it doesn't matter. I now need to measure the resistance end to end of each conductor. Because these are the same size conductors, they're all going, or should be, the same value of resistance. So I'll measure this, 0.23. Now I do the blues or the neutrals. It should be within 0.05 of 0.23, so that's close enough. And again, I now need to do the browns or the line conductors end to end. And the value should be very close to 0.23. What I need to do now that I've got the measurement of 0.23 for each conductor is join together one marked line conductor to an unmarked earth conductor and a marked earth conductor to the unmarked line conductor. Might sound complicated, but basically I'm going to join the marked one to the unmarked one on both occasions. As you can see, I've now joined one marked one to an unmarked one on each case, so you've got a cross connection, which is really a figure of 8. Make sure the connections are tight, so it's usually better to use a block connector if you possibly can. What I'm going to do now is take a measurement here to give me an indication of the value which I should get at each socket outlet. In reality, it should be half of one of the original measurements, so 0.11, 0.12 would be what I'm expecting to get. Okay, that tells me what I should get now at each socket between line and earth. I'm going to carry out a test between line and earth at each socket. Need to make sure the switch is turned on, of course, and I'm going to use a little test box. I'll plug that in. Place my 2 probes between line and earth, and I should get a value of between 0.12 and 0.17. Providing it's within 0.05 of the original measurement, I haven't got a problem. And that should be the same for each socket outlet. I'm now at the last socket. I'm just carrying out the final test. Up till now, they've all been within 0.05 of the original value. Take the reading again, and again, perfect reading. That tells me that all of these sockets are on the ring. The highest of these these values which I've taken, I'd record down as my R1 and R2 value for the ring. But of course, my job's not finished yet because I still need to use line to neutral connections to make sure that the polarity of the ring is correct. I've now cross-connected the line and neutral conductors. It doesn't really matter whether you do the line and neutral first or the line and earth first. There's no preference, but of course the value you record is the one between the line and earth. I need to go again round every socket and test now between line and neutral. Need to make sure the switch is turned on. Put my probes in, and I should get a value again of around 0.15. I'm now at the last socket, just going to repeat the test again. Up till now, all of the values have been correct. If I take a reading, again, the value should be around 0.15. And as I said, providing it's within 0.05 of the original value, we haven't got too much of a problem.